How can we draw the phasor? First point, the line segment or length of the line segment is equal to Vm or Rn. That means the length of the line segment equal to Vm or Im. Vm means AC voltage, maximum AC voltage. Im means maximum AC current. The line segment, for example, I draw a diagram. This line segment represents the length of line segment is equal to Vm or Rm. So they have to represent a car. This is the first point. Second point of the phasor will be the angular velocity is equal to angular frequency of the AC. Angular frequency of Vm or Im of AC. This is second point. And the third point will be phasor always drawn with the vertical axis, which shows instantaneous voltage or instantaneous current at that moment. For example, I draw that this is the phasor diagram. The x-axis, we know the label x-axis. This is y-axis. Now I am going to draw that. For example, V is equal to Vm sin omega t. This is called instantaneous voltage, maximum voltage, sine wave, and angular velocity. This represents Vm sin omega t. This represents with the y-axis shows instantaneous voltage or instantaneous current of the AC. Then final thing that, for example, this is the length of the line segment, shows the arrow mark. This is the phasor. This phasor makes an angle with the x-axis, shows theta or omega t. This phasor Vm makes an angle theta with the x-axis, shows the phase difference between phasor and the current of AC voltage. That means this phasor makes an angle theta with the x-axis, shows the phase difference between voltage and the current. Children, now we are going to see phasor diagram. What is meant by phasor diagram? Phasor diagram is the diagram which shows relationship between various phasors and the phase relationship between them. Now I am going to draw the phasor diagram. For phasor diagram, I should take there are two axes. One is y-axis and another is x-axis. First one is line segment. That is line segment shows that Vm or Im. That is shows O is the origin. This line segment may be Vm and OA, that is OA represents phasor. That is, you know, that is instantaneous voltage V is equal to Vm sin omega t. I am going to draw phasor diagram for this instantaneous voltage and the peak voltage sin omega t. OA represents that is maximum value of current V voltage Vm. So now this represents the projection of phasor with the y-axis, shows instantaneous voltage Vm sin omega t, and this phasor makes an angle with the x-axis, shows phase difference between current and the voltage. And another thing that this is the instantaneous voltage, this is angular velocity. I am going to draw with the voltage. This is the voltage and the origin. This is the origin. So 0, 0 to pi and 2 pi and omega t. So OA represents maximum voltage Vm. Vm sin omega t instantaneous voltage projected to the y-axis, and omega t is the angle between phasor with the x-axis, and this is the voltage, instantaneous voltage 0 to pi and 2 pi. So far we see the phasor diagram. Phasor diagram is the diagram shows phase relationship amongst the various phase diagrams or the phasors. Hello children, now we are going to see the role of resistor in AC circuit. That means what are the character exhibited by the resistor which is connected in the AC circuit. Let us see that. Are containing in AC circuit. AC circuit, we will see now. Are containing AC circuit. Consider there is AC circuit. AC circuit containing resistors R. This is AC circuit. A circuit has a resistor R, and this is the applied voltage V is equal to Vm sin omega t. That means V is equal to Vm sin omega t is derivative number 1. This is called applied voltage. When we apply the voltage in the AC circuit, current flows in the AC circuit, I flows. I flows in the AC circuit. Due to flow of current in the AC circuit, potential drop takes place across the resistors. Potential drop takes place across the resistor. That means, what is the potential difference? VR is equal to IR according to Ohm's law. Derivative number 2. With the help of Kirchhoff's law, according to Kirchhoff's law, the sum of potential difference in a closed circuit is equal to 0. That means V minus VR is equal to 0. This is very, very important. Now we have to substitute that V is equal to VR. That means we know very well applied voltage V is equal to Vm sin omega t. Now we have to substitute the value Vr. V is equal to Vr is equal to Vm sin omega t. What is Vr? That is equal to IR. IR is equal to Vm sin omega t. Now we have to find out that current how much I is equal to Vm by R sin omega t. That is derivative number 3. Compare the derivative numbers 1 and 3. Compare the equations 1 and 3. 1 is V is equal to Vm sin omega t is the applied voltage. I is equal to Vm by R sin omega t is the current. So now Vm by R is equal to Im. Im is the maximum current. So I write now that. So I is equal to Im sin omega t, derivative number 4 from equations 1 and 4. we should understand clearly that there is no phase difference between the voltage and the current in an AC circuit. Both are traveling in phase. Now we are going to see phasor diagram and the wave diagram for R containing AC circuit. Now we will see the phasor diagram of R containing AC circuit. So we have to draw x-axis, y-axis. First of all, we have to draw for voltage. OA shows instantaneous voltage, and due to that, OB is called instantaneous current. That means maximum voltage and maximum current. And Vm sin omega t shows instantaneous voltage, and Im sin omega t shows the instantaneous current. And this phasor makes an angle omega t with the x-axis, shows the phase difference between current and the voltage. Now omega is the angular velocity. The corresponding voltage diagram, see that O is the origin. The waves are flows as voltage to 0 to pi and then pi to 2 pi. The same as current will be from origin O to I, then pi, then pi to 2 pi. Both voltage and current shows no phase difference when the R is connected in the AC circuit. Now we are going to see an AC circuit containing only an inductor. That means, what is the role of inductor when it is connected in the AC circuit? Let us see that. So, AC circuit containing only an inductor. Now diagram. This is the diagram symbol for inductor AC source. This is the simplest diagram for AC circuit containing inductor. Applied voltage will be V is equal to Vm sin omega t. Now we will see that one by one. V is equal to Vm sin omega t is the applied voltage. Whenever we apply the voltage in the AC circuit containing inductor, back EMF or self-induced EMF in the inductor, that is psi is equal to minus L di by dt. L di by dt. Now, the derivative number 2. We know that according to Kirchhoff's law, the algebraic sum of the voltage in a closed circuit is equal to 0. That is, instantaneous voltage plus induced EMF is equal to 0, or V is equal to minus psi. Substitute the value, that is Vm sin omega t is equal to minus L di by dt. That is Vm sin omega t is equal to L di by dt. We need only current. So di is equal to Vm sin omega t into dt by L. This is the process. Voltage is dependent on time, so we have to integrate it. So integration of di is equal to integration of Vm by L sin omega t into dt. Now let's see, that is rough work. Integration of di is equal to I. This is constant. This is constant. We should take out. That is integration of di is equal to Vm by L integration of sin omega t into dt. So integration of sin omega t into dt. Substitute if integral sin omega dt minus cos omega t. We have to integrate omega with respect to t by omega. Substitute this here. So integration of dA will be I and Vm by L and minus cos omega t by omega. Take the omega. Other side I is equal to Vm omega L. So minus of cos omega t. Now minus cos omega t, that means minus cos omega t is equal to or minus cos theta is equal to sin 90 minus theta, that is minus cos omega t is equal to sin pi by 2 minus omega t. Now we write minus cos omega t is equal to sin omega plus cos omega t is equal to sin omega t minus pi by 2. We are going to take this value for AC containing pure inductor. Now let us see what is the value we have substituted. See, now I is equal to Vm by omega L. Instead of minus cos omega t, we should write sin omega t minus pi by 2. This is the derivative number 3. Now Vm by omega L is equal to Im. That is the maximum current flows in the inductor containing AC circuit. Now I is equal to Im sin omega t minus pi by 2. Derivative number 4. Now compare the equations. Compare the equations 1 and 4. This is the voltage. Applied voltage V is equal to Vm sin omega t. This is the current I is equal to Im sin omega t minus pi by 2. When we apply the voltage in the inductor, voltage will flow ahead of 90 degree than the current, or current lags 90 degree than the voltage. This is the role of inductor when we connect the inductor in the AC circuit. We are going to see phasor diagram and wave diagram for inductor containing AC circuit. Y axis, X axis, OA represents Vm and OB represents Im, maximum current, and omega t is the phase difference between voltage and the current. Vm sin omega t is called applied voltage. Im sin omega t minus y by 2 shows the current produced in the inductor. Here see that omega t minus y by 2, here sin omega t, there is difference pi by 2. That means current lags the voltage by pi by 2. That means current comes behind the voltage by 90 degree. Now this is the wave diagram. So 0, that is voltage starts from 0 to pi and then goes to 2 pi. But here see that current will be differ phase angle of pi by 2, starts from pi by 2 to and then pi and then goes to 2 pi, that is omega t. This is the diagram shows that phase angle between the current and the voltage. Maximum current Im is equal to Vm by omega L. The same as for resistor, maximum current is equal to Vm by R. So compare these two derivatives. That means derivative number 1, derivative number 2. So here omega L plays the same role of resistor. So the resistance offered by the inductor, which is called inductive reactance. Now I write that omega. Now I write XL is equal to omega L. XL is equal to omega L. Here omega is equal to angular frequency of AC current. Now omega is equal to 2 pi f. Now I write that XL is equal to 2 pi f into L. For DC current, no frequency. That means frequency is equal to 0. So an inductor offered zero resistance for DC. Only an inductor offers resistance for AC current. Now we are going to see capacitor connected to the AC circuit. That means AC circuit containing pure capacitor. What is the role of capacitor when connected to the AC circuit? That means C in AC circuit. That's all. See that capacitor has a parallel line which is considered as capacitor. This is the AC supply. Applied voltage will be V is equal to Vm sin omega t. Applied voltage will be V is equal to Vm sin omega t. Derivative number 1. When the applied voltage is applied in the capacitor, charge will be stored in the capacitor. The instantaneous charge will be instantaneous charge will be Q, and the EMF across the capacitor. Capacitor is Q by C. According to Kirchhoff's law, we'll write that applied voltage minus Q by C is equal to 0. Now DC is equal to Q. What is the value of V? V will be Vm sin omega t, and along with C is equal to Q. We know the current definitions. I is equal to dq by dt. That is, I is equal to dq by dt. Here, I is equal to d by dt. Q value will be C Vm sin omega t. That's very important. Now we have to differentiate. Before we differentiate, we should take out the constant value, that is capacitance of capacitor, maximum voltage, both are constant. We should take out that remaining, that is I is equal to C Vm. Remaining will be d by dt sin omega t. Differentiation of sin omega t cos omega t. That is I is equal to C Vm cos omega t. So omega we have to differentiate with respect to t will be omega. So I is equal to C omega Vm sin omega t. We write the C omega. I is equal to Vm by 1 by C omega cos omega t can write like this. Cos omega t means sin omega t plus pi by 2. Now this will be maximum current. I is equal to Im sin omega t plus pi by 2. Derivative number, if you take derivative number 2, compare derivative number 1 and 2. 1 will be e is equal to Im sin omega t. 2 will be I is equal to Im sin omega t plus pi by 2. When the applied voltage is when the AC voltage is applied in the capacitor, current release the voltage by pi by 2. Now we are going to see Phasor diagram of capacitor connected in the purely AC circuit. Children, now we are going to see Phasor diagram or wave diagram for AC circuit with C. So here OA is the maximum voltage and OB is the maximum current, and omega t is the phase angle makes OA with the x-axis. Here Vm sin omega t is the phasor projection with y-axis, that is applied voltage. Here Im sin omega t plus pi by 2, this is the current. The wave diagram, see the wave diagram, voltage will be, see the voltage starts from origin. This is the voltage 0 to pi and then pi to 2 pi. But see the current goes head of voltage. Current goes head of voltage by pi by 2. It starts before 0. So 0, before 0, 0, pi by 2, and then it's 2 pi omega t. This is the phasor diagram of capacitor connected to the AC circuit. Now we are going to see capacitive reactance. Capacitive reactance. That is, capacitive reactance will be Im is equal to Vm 1 by C omega. The same as what resistor will be Vm by R. Compare these two derivative 1 and 2. That 1 by C omega plays the same role of resistor. So the capacitor, the resistance offered by the capacitor is called capacitive reactance. That is, Xc is equal to 1 by omega C. Omega will be 2 pi f. That is, Xc is equal to 1 by 2 pi f into C. For the DC current, for DC, F will be 0. Now the capacitive reactance of capacitor will be 1 by 0. So X is equal to infinity. When the DC current flows into the capacitor, it blocks the DC current.